this video, we're going to explore how you could take a Bradford type data set where you've got absorbance versus known concentrations of proteins and graph that data, do a trend line and an equation fit and an R-squared value, and ultimately then determine the concentration of an unknown protein source like milk right here. So first we've got, if we take a look, we've got 3 cuvettes or 3 tubes. And for each tube, we had 3 known concentrations: 0.20 milligrams of protein per milliliter, 0.40 milligrams of protein per milliliter, and 0.60 milligrams of protein per milliliter. And we can see that for each tube, we did 3 trials. So we would like to take the average. So then we just tell it that we want these data points, close parentheses, return. And then we're going to take that and tell the equation to apply to all. And so we can see now that for the 0.20 milligrams of protein per milliliter, that it had an average absorbance of 0.31. For the 0.40 milligrams of protein per milliliter, had an average absorbance of 0.55. And for 0.60 milligrams of protein per milliliter had an average absorbance of 0.80. Please note I am not marking uncertainties. This is definitely not how you'd form it in a lab report. This is just how you could lay it out in Excel to actually analyze your data, where you ensure that you are analyzing the data how you want to analyze it and not letting the computer decide how to analyze it. And then finally, just let's get a jump start on something we'll need later and average out our absorbances for our unknown milk dilution. There we go. So let's go ahead and insert. So we're at insert now, and we want a scatter graph because we want to do an XY graph, but we don't want to connect the dots. Let's just move this a little bit out of the way so we can see what we're doing. And then we want to go through and insert. And here we go. Now we want to select data. So we need to tell the computer exactly what we want. So we're going to click Add, and we're going to tell that this is average absorbance versus concentration of protein. You can come up with a much more creative title. This will just be a placeholder for the moment. So we need to make sure that we put the right thing on the right axis. So we would like our dilution, so we take a look right here, to be the X value. So we don't want actually the words, we want the actual data. So now we go through and select that. And then our Y values are our absorbance. This is Beer's law here that we're applying from chemistry. Okay. Okay. So now we've got that basic fundamentals. We've plotted our 3 data points, which ideally you would have a lot more known concentrations than 3, but you at least have to have more than 2. Otherwise, you're going to run into problems when you do your R-squared value later. So let's go ahead and right click and not there. There we go. We need to actually click on a data point. Now we can right click, and now we can add a trend line. And so we want, this is a linear trend line, which is usually the default, but always double check. And we want to set it at the intercept because when there is 0 concentration, there should be 0 absorbance if you appropriately blanked your spectrophotometer. And again, following Beer's law. And then we want to display our linear equation, our y equals mx plus b, but b is 0, so y equals mx. And then our R-squared value to see how well does our linear equation actually predict the data points that we collected in the actual lab. So close. And let's go ahead and move those data points there. So it's just a little bit nicer looking. Okay, now let's go ahead and move the chart into something a little easier to deal with. New sheet. Okay, that's a little easier. It's a little bigger to work with. Okay, so let's go ahead first of all and increase the font size there. Something just nicer to work with. Okay, so our slope here is 1.3655. Okay, but we'll notice our X and Y axes are not labeled. So let's go through, and that's in layout. And we have axes, and let's go with the vertical one first. Oh, I don't like that one. That annoys me when I'm reading it. So let's choose the other one. That's much better. So remember, the y-axis is the absorbance reading of the spectrophotometer at our made-up 635 nanometers wavelength of light. So this is absorbance, and the uncertainty of our spectrophotometers is plus or minus 0.001. Notice there are no units associated with absorbance. We just call it the absorbance, but you should specify what the at what wavelength the absorbance was taken at. So the absorbance wavelength was taken at 635 nanometers. That's the wavelength of light that the spec was set to. Okay, that's a pretty small font, but it'll do for the moment. And then let's put let's put our horizontal in. Okay, and our horizontal axis, our x-axis, is our concentration of bovine gamma globulin protein. That was our standard protein. And that was taken in milligrams of protein per milliliter for our units. Okay, now whether you keep this part or not, and whether you keep it right next to the graph or a separate part of your graph, that's a preference in just basic layout. So let's just take a look at what we have here. So we have our trend line, and then our R-squared value tells you how well does this trend line with this equation predict these actual data points that were from our data analysis. Remember, those data points are not actual red data points, but the averages of our 3 trials for each known value of protein. It would be great to throw on error bars for our data points to show the spread for our averages, but let's just keep things pretty basic and straightforward today. Okay, and then finally, if you want to move this into a Word document, you can go ahead and right-click and copy, and then just open up Word. And then you have your whatever is going on in your lab report, and then Control V, then you can resize it to an appropriate size. And then remember, when we're formatting, it should have a title for the graph. I'm going to shrink you so you're a little bit better looking. Notice that the unknown data is nowhere to be found. This is only known values. So you'd probably want to modify that title because that title is kind of boring. And then below the graph, you need to identify this as, come on up. There we go. As figure, let's say this is figure 3 in your lab report. You had 2 figures previously, and you're going to describe. Oh, look, it's a typo. So unusual for me. Let's throw some comments in there. Describe the average known value, absorbance values. Blah, blah, blah. Do not jump to conclusions in the process data section. Save that for your actual conclusion and evaluation section. Okay, and there we have it. Now, the final thing is, how do we solve for an unknown? Well, let's see. We now have an equation. Let's just snag that equation, and I'm going to just pull that back to Excel. So copy, go back to Excel, go back to our sheet. And again, this is just our worksheet right here. So I'm just going to paste it right here, Control V. Okay, so now we have our average Y value. Our average absorbance is 0.54. Okay, please remember that's your Y value. So that tells you that 0.54 is equal to 1.3655x. So if we wanted to solve for x, we divide both sides by 1.3655, doing basic algebra. I'm going to actually make the computer do that for me. So it would be as such, 0.54. You probably wouldn't do this in Excel. You probably would do this on a calculator. It'd just be a lot easier, but I'm trying to just show this to you. And then we see that we get 39.54, blah, 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 way too many sig figs. So we did division here, so we're limited to 2 sig figs. So let's go ahead, oh, wrong direction, get it down to, there we go, 2 sig figs. Oh, that makes it fun because now we're going to have to deal with awkward 0. So when you're putting it in your computer, make sure, I'm going to leave it with 4 sig figs, but remember it should be down to 2 sig figs in your actual lab report. So what does that mean? That would be your milligrams of protein per milliliter of protein. Now, what else can you do with that data? Well, you could calculate your percent error. So then you would have to know what your known what milk should be for its concentration. Just make sure you're working in the same units, and make sure you then, for calculating percent error, that's the observed minus the expected, and then follow basic algebra. Observed minus expected divided by expected, and then multiply by 100, or you can hit the percent sign. And so that is all I'm going to go over right now with you for some fundamentals of how you can use Excel to analyze data and graph data.